2. And if you want to follow along in the textbook, it's pages 9 to 11. So 1.1, we spent a lot of time doing definitions. 1.2 will continue. The two main things, and in the synchronous activity that you do, we'll delve more into this, but the differences between the two. So in geometry, you're going to see postulates and you're going to see theorems. And postulates are, so a postulate is a rule that is accepted without proof. So, like, we'll see postulates when it relates to geometry in a second and math, but you can think of postulates as just universal facts, like the sun rises in the east and sets in the west would be considered a postulate. The proof is just, you see it happening in a way. So there's no written proof. Whereas a theorem is a hypothesis or a rule that is proven to be true. So these aren't just well-known facts. Someone had to prove that they were true. Like one popular theorem that we'll talk about over and over again is the fact that sum of all the angles in a triangle always adds up to 180. So that is a theorem. There's a proof for it. In the next lesson, we're going to see the proofs for midpoint and distance theorems. So those are all rules that were proved to be true. Okay, but for today, we're going to stick to postulates. So the segment addition postulate says, so segment addition, if you break this word down, we know we're dealing with segments and we're adding them together. So, and as I fill this out, the points and references is referring to this diagram here. So if B, remember, if I just write the letter with nothing around it, I'm referring to point B. So if point B or B is between A and C, then segment AB plus segment BC is equal to segment AC. So the segment addition postulate says that if you have a point in between 2 points, then the length of the entire segment can be broken up into the segments that make it up. So AC is the entire segment, AB is one piece, and if you have BC is the second segment. So both of these together gives you the entire segment, which is AC. Okay, so there's actually 3 different segments here. And remember, the sum, or you can say the length of the segment, is equal to the sum of its parts. So this is the length, and it's equal to the sum or the addition, sum means addition, of the parts that make it up. Okay, so we're going to be using this, and what does this look like in application, right? Knowing this postulate, we can actually figure out missing lengths. So the 2 examples here, now this means I know the length of AC is 15, and the 5 is in between A and B, so that is the length of AB. So the length of AC is 15. The length of AB is 10. So they want you to find BC here. So they want you to find BC or this missing segment right here. Now, according to the segment addition postulate, you know that AB plus BC is equal to AC. And I would actually encourage you to write these statements out, even though maybe some of you can easily tell because you're very visual that this is 10. But these statements, writing these out right now would be good practice because you're going to have to write these out moving forward. So BC here is 10. And you can even substitute and check and do all of that. Okay. Similarly, here, it's the same idea. BC in this case, it's the same segment addition postulate that we used. BC would be equal to 12, right? So BC is 12. Okay. The next thing we're going to talk about is congruent statements. Statements that have the same measure. Now, there is a difference between, and if they have the, let me stop jumping forward. If they have the same measure, you can say that they're congruent. So the way you would read this is AB is congruent to segment PQ. Now, the diagram for this could be and the way I know that they're congruent is I can put these tick marks. So this tells me the length of this, I don't know what it is congruent to the length of this. Okay. Now, this is new. This symbol is new. You probably haven't seen it before geometry. The second statement here, AB is equal to PQ. You probably have seen it. You've seen quantities be equal to each other. Well, what is the difference? If I say AB is equal to PQ, then that means the segment AB has the same length as segment PQ. I get a lot of questions of, well, what is the difference? Well, the difference is, in this case, in the second case, you know the length of PQ as a number, and AB as a number. So anytime you have quantities, and these are definitely still congruent, but because you have a quantity or a number that represents this, in this case, you would say they're equal. Okay, it's a subtle difference. So when they represent numbers, they're equal. In contrast, if there's only figures and you see this notation and nothing else, then you would say they're congruent. Okay. And are all congruent segments equal to each other? Sometimes, but sometimes you don't know the measure. You don't know the numerical quantity of that segment. So you can't really say they're equal. It would be more appropriate to say that they're congruent. All right. Okay. So, but this notation is going to be really important. In the diagram, here's a third example. Points P, Q, R, and S are collinear. We talked about this yesterday. The idea when points are collinear, they're on the same line. So P, Q, R, S are all on the same line. So they are collinear. And notice when I do this, I'm constantly labeling my diagram. I know PS is 46. So the length of the distance between point P, this is hard, all the way to point S is 46. PR is 18. So this is how I'm going to denote length here. PR is 18. And PQ is equal to QR. Now, in this case, some of you might say, well, we don't know the measure. How can they say they're equal? Well, because we're going to figure out the measures because we know some of the numbers already. okay? But because they're equal, all segments that are equal, they have to be congruent to each other. So if they're equal to each other, you can assume that PQ is congruent to QR. You don't know the measure of it yet, but you can make that assumption based on this. Now, you could, I like to fill these out at the end, but as you can probably see it visually here, the distance between P to R is 18, and Q is exactly in the middle. That's what these tick marks mean, because this length and this length is equal to each other. So this PQ and QR both have to be 9. So PQ is 9, and there's no units, so you don't have to put any. QR is 9. Now, knowing that, you can figure out RS, right? Because RS goes from here to here. And RS plus all of this stuff, which is 18, gives me the entire segment, which is 46. So segment addition postulate again, you can say PR plus RS is equal to PS, the entire thing. And PR here is 18. Plus RS is what I don't know, is equal to the entire segment, 46. So RS, you treat, it's a one-step equation, subtract 18 on both sides, and you should get 28. So RS is 28 units. Okay, now QS, starting from point Q, it's like I'm walking all the way to S and I want to know how many steps. Well, from Q to R is 9, so I know it's going to be 9 plus R to S, or R to S or S to R, same thing, is 28. So these two together give me the length of QS, which is 37 units long. Now at this point, you can pause and try the second example on your own, and then come back, or you can keep going. Of all of these segments. And you know that they're collinear, all of these points. So VZ is 52. XZ is 20. And then you know all these, the WX, XY, and YZ are all congruent. So you can have more than 2 segments be congruent to each other. That means this piece of my line segment and this piece all have the same measure. Okay. Now, and then they're asking you to find the measures of all of these other things. I think the easiest way is to, because you know XZ, this segment is 20, and XY and YZ are the same length, you can logically figure out that XY and YZ have to be 10. Now, these two segments are congruent to WX, so this segment here is also 10. And that's our first blank here. WX is 10. Now, you can find VW now, right? Because VW plus WZ, that means all these 3 segments together. So 10 plus 10 plus 10 gives me 30, gives me the entire length of VZ, which is 52. So I would find VW next, and I would get VW by doing 52 minus 30, I'm sorry, not 20, 30, which gives me 22. So VW is 22, this segment right here. And then we can go and fill in the blanks here. Let's see, WZ, we already sort of said has to be 30. So to figure out the lengths, this is a 0. It's like you're walking from one point to the other end point. So VX is going to be this piece right here from V to W and then from W to X. So 22 plus 10, 32. WY is going to be 20 because it's made up of this piece and this piece right here. And VY is made up of this piece, VW, and WY, which is 20. So VY is going to be 42. 22 plus 10 plus 10. Okay. Now the last example has to do, well, not last example, but second to last example has to do with the same idea. So we're using the segment addition postulate, but now we have some algebra here. So you want to find VW, but first we need to find X. So according to the segment addition postulate, I know TV plus VW is equal to 32. And TV is 3x plus VW, x plus 8, is equal to 32. VW is an expression, x plus 8, right? So it's not just x or 8, it's together. So now you can combine like terms. 4x plus 8 equals 32. Subtract 8 on both sides. 4x is equal to 24. Divide both sides by 4. X is equal to 6. Now, VW is 8 more than 6. So x plus 8, which gives me 6 plus 8, which is 14. So the length of VW is 14. Okay? Now, you can do the same thing here. For the interest of time, I'm going to actually skip this problem, but I'll give you the answer. So you should get x is equal to 5 and yz is equal to 14. If you want to see the work for it, come see me during office hours. Just don't want this video to be overwhelming. And the last example here, and this is what I was talking about earlier, is you might not always be given a diagram, but you will be given information that will help you draw a diagram. So point S is in between R and T on ST. So, I'm sorry, on RT. So point S is in between. Well, it doesn't actually have to be in the middle or closer to, it doesn't matter because they didn't specify. I'm just going to put point S right here. And this is my segment RT. So now using this diagram, I can now label. So essentially it's like the problem before, but you're not given a picture. So you're given that RS is 2x plus 10. ST is x minus 4. And you're also given RT here. So RT, the length of the entire segment is 21. So you should think about what equation can I write to solve for x? Well, I can write, according to the segment addition postulate, I can say RS plus ST is equal to RT. RS is 2x plus 10 plus ST is x minus 4 is equal to the entire length, 21. So now I can combine like terms. So 3x plus 6 is equal to 21. Subtract both sides. Subtract 6 from both sides. And then finally divide by 3. So x is equal to 5. But again, the question kind of asks you to find both segments. So RS is going to be 2 times 5 plus 10, which is 20. And ST is going to be 4 less than 5. which is 1, into your original diagram. And that will let you know if you're actually on the right track here. So you can see that our S we got was 20, ST is 1, and together they make up the length of the segment, which is 21. Okay. Now, I'm again not going to go through this in detail. It's the same diagram, and it's actually the same statement you would write, but you'd substitute different expressions. So the expression that you should have gotten, RS plus ST is equal to, okay? So then you combine like terms, there's variables on both sides, so you have to move stuff around. But you should get X is equal to 10, and RS is equal to 14, and ST is equal to 32.